Hey guys, how are you? Let's review some pre-calculus AP questions. We have a function here and it says the figure shows the graph of the function f on its domain. -4 through 4. The points -2, 0, 1, 0, and 3, 0 are on the graph. The function g is given by g of x equals 4 times 0.6 to the x. Now, look at part A here. AI. The function h of x is defined by the composition g of f of x. Find the value of h of 1. Okay, so let's do that. It's going to be like this. H of 1, that means specifically g of f of 1. So remember, you got to read this from the inside to the outside. So f of 1, if you look here, is very carefully, let's say it's 0. So you're going to have g of 0, and that's the y coordinate from 1 comma 0 on the graph of f. And then g of 0 would be just found by doing 4 times 0.6 raised to the 0. So 0.6 to the 0 is 1, so you have 4 times 1, which is just 4. Find the values of x for which f of x equals 0, so f of x equals 0. Okay, so that just means you look through the graph here and you pick out anything that has that condition. So remember, this 0 on the right side that you see here, this means y equals 0, right? And the x here is the unknown quantity. So you go by that logic. So if you look at it carefully, let's see here. If you look here, you see that when x is -2, y is 0, and then when x is 1, y is 0, and then when x is about 3, y is 0. So we can have the following. X equals -2, x equals 1, and x equals 3. -2, 1, and 3. Okay, let's come to the next thing. So it says find all values of x as decimal approximations for which g of x equals 2. Okay, so over here. So remember, g of x is defined as what? 4 times 0.6 raised to the x. We want that to be equal to 2. So we're going to do 4 times 0.6 raised to the x equals 2. And then you just solve this for x. So you're going to have 0.6 raised to the x equals 2/4, which is 1/2. So it's going to give you 0.6 raised to the x equals 1/2. In other words, divide the 2 away. Okay, so then you take the natural log of both sides. So ln of 0.6 raised to the x equals ln of 1/2. Bring the x down by the power rule for logarithm. So it's going to be x ln of 0.6 equals ln of 1/2. And then ln of 0.6 is just a number, so you can divide by it. So it's going to be x equals ln of 0.5. For the sake of simplicity, let's do it this way. Yeah, divided by ln of 0.6. Okay, so you put this in your calculator and get some number out of it, right? So like the exact answer would be ln of 0.5 divided by ln of 0.6. That would be the exact answer. But you gotta approximate, so just put that in your calculator. I don't think my thing here that I'm using here can do this, can it? It can, 1.357. There you go, so 1.357. Determine the end behavior of g of x as x goes to positive infinity. Okay, so you're going to have this. They want to use limit notation. So you're going to do limit as x goes to positive infinity on the bottom. Look very carefully. And then it's going to be 4 times 0.6 raised to the x. So look at this number. First of all, this is exponential, right? So like 0.6 is greater than 0. And 0.6 is not equal to 1. That means this is an exponential function. But more specifically than that, 0 is less than 0.6, which is less than 1. That means it's decreasing because this number here is less than 1. So I'll say the following. The limit as x goes to positive infinity of 4. The 4, first of all, is a constant. Even if it's a constant, you can pull it outside the limit like that. So it's going to be 4 times the limit as x goes to positive infinity of 0.6 raised to the x. So it's going to be 4 times 0. Okay, you can graph 0.6 to the x, look at the graph, and x goes to infinity, and you see the y coordinate approaches 0. So it's just in 4 times 0, which is 0. It approaches 0. Okay? Determine if f has an inverse function. Well, look at f here. Does this have an inverse function? Definitely it doesn't. It doesn't because it fails the horizontal line test, right? Like you can tell, you have the same y coordinates, say over here, -1 corresponding to 3 different values of x. So the last part is give a reason for your answer based on the definition of a function and the graph of y equals f of x. Graph fails the HLT, horizontal line test. What the horizontal line test really is, look at it, right? If you think of the vertical axis as the independent variable and the horizontal as the dependent, then you just failed the base. It's not a function anymore, right? One more time, think about what I've just said carefully. Maybe listen to it a couple times. Thanks so much for watching. Leave a like if it's helpful.